Ladies and gentlemen, what a glorious day. Delighted to see you. My name is Alfred Biehler. I'm one of the cloud specialists at Google in London, looking after data migration and management. And I'd like my two colleagues to introduce themselves as well.
Hi guys, my name is Kiran Shenoy. I am a data management specialist CE within Google Cloud, based in London.
And my name is Ahluwalia. I'm a product manager for Google's transfer products based out of California.
Thank you very much. So our plan is to give you an overview of the different data technologies we've got and the process involved in moving towards the cloud and how to get your data there, all of your data, structured and unstructured. And we'll do that, but also give you some best practices and deep dives into some of the bits as we go through the journey. However, to make the journey a little bit more interesting, we're going to do it with the use of a little bit of a fictitious company. So I'm going to pretend to be the customer. I am the manager. Let's say I'm the CTO. I always wanted to be a CTO. I'm the CTO of a company called Quantum Cowboys. Okay, Quantum Cowboys, here we go. So Quantum Cowboys, we build products that help supply the whole quantum physics, quantum computing industry. Here to announce one of our really unique products is a photon generator. Yes, you can have photons generated from a mobile phone. And we've got lots of other products, right? Things like when you order some of our really cool products that run sort of 0 Kelvin, we simultaneously both ship it and don't ship it to you. And it's not true that some of our customers receive dead cats in boxes. That didn't happen, right? So that just gives you a sense for the business we're in. We do have a lot of data on site and a lot of apps running, but it's all currently on premise. And you can imagine some of the challenges we're facing with our Oracle databases and MySQL databases. And it's great to hear that Google has got SQL Server now available as well. So there's some great opportunity for us to move to the cloud. And in fact, when we look at the opportunities, it's clear that the kind of scale that we're dealing with, my employee database have got employees not only globally, but in an infinite number of parallel universes we've got employees, right? So it's a huge employee database. That requires some movement if it moves to the cloud, right? So there are challenges around the scale that we need to deal with. There's certainly challenges around the maintenance of databases on premise. I'm sure you know that, right? Patching the machines, dealing with the network cards, dealing with drivers that need to be updated, and the outage that causes, dealing with the data growth, dealing with the indexes, dealing with all of that stuff is hard work on premise, and not to mention the cost of actually maintaining the licenses for all of those products. So we have got a desire to move away from some of this and move to the cloud, and we know that there's actually a great trend of that happening. In fact, data suggests, the research reports that I read suggest that next year, 75% of all databases will be running in the cloud or moving to the cloud, right? So that's a huge number, and in fact, 2015, we expect that, 2015 is already gone. Yes. 2025, we expect that the data that's stored in the cloud will be 5 times than it is today, right? So the growth is incredible. But the truth is, there are some challenges, Kiran, that I experience in this whole thought of just moving to the cloud, right? How do I get all these multiple applications, the spaghetti of thousands of databases? I don't even know where all my databases are, right? To understand that and to move that to the cloud, it just seems like a daunting task. I'm assuming some of these would need to be changed in terms of how the data is queried or where it lives or pointers to it, and some of the applications need to be changed. So, I mean, trying to understand how I assess this and how I move forward with this is a daunting task. It drives me nuts, right? So, with that, it feels like you guys are laying down tracks faster than I can consume. Can you give me a sense for where I start, what the steps are? In fact, let's start with, can you tell me about some of the products you've got available?
Yeah, sure, Alfred. So before we talk about data migration itself, moving your on-prem databases to GCP, let's go through, touch base on some of the data management portfolio we got. Starting with relational databases. If you have Oracle, MySQL, or PostgreSQL sitting on-prem, we have equivalent Cloud SQL, which you can, if you have MySQL or PostgreSQL or SQL Server, you can go to Cloud SQL. Then we have Spanner, which is a globally scalable relational database. It gives you the best of NoSQL and a SQL database. Next is also we have data warehouse. In case of data warehouse, we have BigQuery. So all the data you collect into cloud have to be analyzed. You have to build analytics on top of it, doing ML operations. BigQuery is another tool you guys can utilize it. In-memory, if there is a requirement for in-memory database where you need very low latency, you have any applications around gaming applications or game dashboards, that's memory store can be a solution for you guys. And finally, but not least, is no relational type of databases. We have Bigtable and Firestore. Bigtable is nothing but it's a columnar stored database. If you have Cassandra, Bigtable can be a good candidate, or HBase. Moving into Bigtable can be a good candidate for you guys. So, okay, we have these portfolio of databases. What if you have databases, old version of databases, you cannot move into these PaaS offerings, which manage database offerings? What do we do? In that case, we have a database on GCE or GKE. For if you can move your databases into GCE. If you have IBM DB2, you can move them. Or if you have MongoDB, you can move them, or PostgreSQL, which are certain features are not goes into a Cloud SQL. Again, you can utilize that. Other than that, we also have strategic partners, likes of Redis, MongoDB, Elastic, and these partners are now available on our marketplace. So you can spin up the databases very quickly and start a journey towards the cloud. So we have all sorts of all kind of options available if you have thought about moving your on-prem to database with different flavors.
So that sounds amazing. It sounds like you've got really a broad set of products that can solve all of my problems. But where do I start? What are the steps?
Before I start this, just take a sense of the audience here. How many of our DBAs here? Any DBAs? One there. Any data engineers? OK, data engineers are there. The reason I'm asking, because in my past life, I was a DBA myself. And I give you one quick incident, real life. I had to do a migration for Oracle from Windows, and this I'm talking years ago now, going to Windows to Solaris, and we have 2 DBAs tasked. We given a 12 hours window to migrate huge amount of databases. And I remember we worked from 8 to 8 in the morning, and we had booked a hotel room nearby a data center. So we take turn to babysit the migration. So I know migration is a hard task, doing the assessment yourself. And it's a nightmare sometimes for DBAs. Equally for if you're a data architect, how do you go about doing that? Which tool to utilize? How do I make sure the data is moved accurately? And remember, it's not just about data. It's about application. Data movement is one part. How do you move the application? All the dependencies involved. What are other applications sitting on top of it? So don't just discuss about or try look about from the data perspective. So that's the key there. So whenever we talk about a plan or any workload movement to cloud, there are 4 steps. So first step is assessment. You have to know your application and database landscape very well. When I say that, what type of database you got? What is its configuration? What are the features of databases are you utilizing in that database? Because over the years, that legacy database have grown organically. You have built new features, custom features. You have to understand that what are the different applications you might have built on top of it. What are the dependencies along it? So you can't just jump and go for cloud. You have to understand what's my application landscape look like, what are the databases are there, how are database connected to each other, are there database links? If you have Oracle, you might have database links going across the number of databases. So those are the key to understand. Once you do that, then you do the planning. OK, I know my database. I did the assessment. So what I can move to cloud now? What I should move, that's the key too. And which order. So you did that planning. OK, you decide, OK, I'm moving X and X databases. And then the real fun start about real migration. You set up a target databases. You do the migration. You do the validation. And we will touch base on this later slide in a bit more in detail. And you should always have a rollback plan. Remember, when you move to target databases, your source should be there, sync all the time. So in case something goes wrong, your applications are not working as per required, as it should be, you should be able to point back to the source database to business continuity. Meanwhile, that's happening is optimize is the last step. Optimize is where you improve your in-house systems processes, your operations process within because things have changed now. You're no more doing patching or no more doing any upgrades. So all these resources until now you are doing all these mundane tasks can focus on business innovations, building better applications. So those are the keys. You optimize, not optimize by TCO perspective, but optimize the resource. How you can go about. So that's the key to remember. You're just not moving your applications and data to cloud, but other optimization has to be taken care of.
OK, so that's a really good overview of the steps. So can you tell me what are the strategies I need to consider when I move? What are the options for my different databases?
So, sorry. One of the key strategy is what type of databases you got. When you do assessment and when you do the planning, when you talk about migrate, we have two types of migration we always recommend. It's homogeneous and heterogeneous. Homogeneous is moving from like database, for example, same flavor, going from MySQL, PostgreSQL, MS SQL Server to cloud equivalent Cloud SQL, or you're going re-platforming them. But before do that, I would always suggest is go to the first two options. Those are very key. People forget sometime. Retire. Look at your landscape of applications and databases. Do you really want to take it to your cloud? Is it possible to retire those applications? Retire those, are they really being utilized? Can you consolidate with other databases? Because these databases, they're for lying around for years, maybe in your data on-premise environment. So that's the key. What you can retire, just eliminate those, so your workload become less for the moment. Second is replacing. If you have, for example, you have a CRM applications with a backend MySQL database. Think about, OK, I need to move my CRM application to cloud. Can you utilize some sort of a SaaS application for that, instead of moving the legacy application to cloud? So those two are very critical there. Rehost. When you talk about rehost, it's just simply lift and shift, your VMs. So your on-premise databases are running on your on-premise environment. You can just lift and shift. So lift and shift, the easiest way to get into cloud. In that way, what happens is you're not changing an application logic. You're not changing any data model. You're just changing the direction of pointing your application in cloud. Easiest way to get on cloud, and then you take the next step going forward of refactoring it. So that's another consideration. And that rehost is important. If you're unable to unable to migrate to managed services like Cloud SQL. And when you talk about re-platform is something like this looks like. I call it, going from MySQL to Cloud SQL or PostgreSQL or Redis to memory store. So in this case, you are using our managed services completely. You're handing our databases to Google Cloud to take care of, so you guys can focus on building new application on top of it. So re-platforming, but you remember you're still using your same database, same flavored database. You're not going like a heterogeneous data migration. The fifth type is talking about refactoring it. Refactoring is where you have Oracle databases or PostgreSQL databases. You've outgrown it, your scalability issue, you have reaching your boundaries of the growth in your environment. Or you need a global scale database now. You are in regional at the moment or operating in a certain region. You want to go global. In that case, we talk about something as refactoring. So for example, you can talk about if you have a MySQL database like Alfred was talking about here earlier on is going to Cloud Spanner. So it's your scalability. You have MySQL database in your on-premise. You want to global scalability. Your business is growing. You have multiple locations across the world. Spanner is the one. So it's an RDBMS database. Oracle can go to PostgreSQL. Suppose you have better ROI. You want to get rid of licensing cost. You want to go open source. That's another way of doing it. Or Cassandra. If you have Cassandra nodes, you want to manage, you don't want to manage it anymore. You want to hand it over to Bigtable. It can do that. So the last but not the least is rebuilding. Whenever you have new applications to be built, greenfield, it's easy to do that. Build native cloud-native solution. So all these 6 factors are important, right from retire to rebuild. So we try to cover all the options when you talk about migration. All these options, and then the optimization is the key too.
That's really useful. Thanks, Kiran. I appreciate this view. I didn't even consider that I could retire some of my things, but you're right, some of them do nothing, right?
Yeah.
So it makes sense. Now, I've got thousands of databases, right? Where do I even start to sort of do this assessment that was step 1 of your guidance?
Yeah. That's the key. Assessment is always the key. I mentioned there's a first cornerstone for any migration success, knowing what you got. Applications, databases, what it's doing, how it's doing, what code you got, what amount of application code or the business code is in the application, what is in the database. Knowing all that is very key, because on that purpose you can decide what database you want to move or you want to get into the cloud. So in that case, we have a partner called Migvisor. Now, Migvisor is an automated database assessment tool. And reason we work with Migvisor because it does the job of assessing the data, all the RDBMS databases like Spanner. It does Oracle's SQL Server, MySQL, and PostgreSQL. If you see a chart there, the reason the chart, it's my own experience, I've learned it over the years, is migration is tough. You spend a lot of time assessment, and when you come to actual execution, you don't have time. You run out of budget. You give less time to DBAs or the team, because I was a DBA in the past. That's what I'm saying, that we used to get less time to do the migration, a lot of time spent on assessment. And even after spending a lot of time, you are not sure, is it exact or not? And you used to fail sometime. So how do you reduce that time of assessment? Which is the key, obviously. You have to do it right. But I want to reduce. I want to get to the market quickly. I need to capture the new markets around quickly. Data migration is done, but how do I reduce the time? So Migvisor is a tool which does it. So what it does, in short, this is a simple architecture of Migvisor. It's nothing. It's all it does. It's a small data collector, metadata collector tool. It's a JDBC tool connecting to your databases. It can run on your laptop. You don't have to install on your production databases or production environment. And it can connect to, and you don't have to collect multiple collectors. One collector can connect to hundreds of databases, all type of databases. So it's one collector, go across all your databases. And what it's going to do, for example, Oracle, it's going to read the AWR statistics, bring all the database details around your configuration, database types, tables, data types, anything and everything is going to bring across and collect all the automated. And it does in hours. It's, the thing which used to take days or months sometimes, it's now so automated quickly towards the first step. Once it does it, it's going to do an assessment. It will give you a next step is, it'll give you like a graph, like as a dashboard. In the dashboard, you have easy, medium, and hard. So how does it do that? So assessment is one part. If my target is PostgreSQL, I have Oracle, PostgreSQL. You can ask Migvisor, hey, my target is on PostgreSQL. What is the compatibility between these two databases? What other database are compatible? Data types are compatible. What I can move easily, and what are the things I have to manually change? So in this case, you can see the easy assessment here. For example, job schedule in Oracle, what is the equivalent in GCP? If you have a data guard, what we can do in it, it suggests how you can do it, how the process involved in the migration, what are the data types equivalent. So you have to drill down. This is the high-level screen I'm showing you. So on the right-hand side, you can see the box there. It's a drill down there. So it'll give you at the attribute level, it goes through all the details. So your DBAs, your data team will have a chance to review what's involved, what do I got, what are the applications that connect to it. And this is one of the example of a difficult one. For example, you have Oracle RAC. How do you implement Oracle RAC? What are the architectural changes you might have to do it around it? What are the, if you have hints, what are the code changes? So before you even start, remember, assess, plan, migrate, optimize. You are at assessment stage. You get a pretty good idea of what type of database you got even before you start the journey. You know what you got by now, right?
So, Kiran, I was hoping you're going to tell me that all of the migrations are easy, but I think you're right. They're not always easy. So tell me, I can imagine that backing up a database and just restoring it in the cloud is one way of getting the data. Is that the only way? Can you tell me what are my options?
Yeah, there are two options. You know, if you have a non-critical databases, you can go for one-time data load over the weekend. I used to do in the past myself. Shut down the database, take the export, recreate new databases, import, voila, it's done. It doesn't work nowadays, right? All the databases are 24/7, business critical, has to be up all the time. So they have to be up and running. You have to migrate the data, but at the same time, your source database has to be available all the time and somehow has to be synced, kept in sync. So in case you want to move, as I mentioned earlier on, you should be able to move back to source databases. So CDC is a very key factor there. So how you move your databases, when your source database is actually running, so there's less business disruption. So businesses are happy when you go and tell them, let's migrate our database, we are doing a database refresh. They will say, how long my database is going to be shut down? If you say 5 hours, they're not going to approve that stuff. So keeping them live, keeping their lights on, you have to migrate the database, right? So one of the examples I want to run through is within Cloud SQL, we have automated. If you're going from MySQL on-prem to Cloud SQL under Cloud SQL, there is an automated process. So in that, you can take a dump of your MySQL database and push it across, create a new instance, dump it on the across into Cloud SQL. And then we have a process inbuilt to replicate it while your source is still there. And once you're happy of the database, you did the validations, did the test, all that's done, your application can be pointed to the new databases. Remember, the applications also can be migrated. Remember, we have other solutions around GCP. We can do that. This quick video I want to run through. Oh, sorry. Is it running?
So Kiran, just tell me.
Yeah, okay.
You say that if I wanted to move a MySQL database from on-premise to the cloud, have you got any specific tools that can make that just happen?
Yeah, in MySQL, what happened? You have an option called migrate. If you go to Cloud SQL console, if you go to MySQL, there's a migrate DB option. So in case of migrate DB, you can create once you define the migrate DB, you define your source, which is your on-prem, and define show your MySQL dump, and it start doing the migration. As it does the migration, it creates the link to your source database, as the dump get imported into the MySQL and under Cloud SQL. Remember, your MySQL on-prem has a binary log enabled. So as the dump is getting imported into the target database, the binary logs will get shipped across, and it gets synced. Unfortunately, the video is not working.
So tell me, I mean, that sounds great,
Yeah.
but what if I have got a database that can't go down at all. So it needs to be up and running all the time. Then I can't just create a backup and restore it because there's a gap, right?
Yeah. If you have a massive multi-terabyte database, a database which is business critical, and you want to migrate it, we have a tool, which is a third-party tool with which our partner got Streams. And they are here in the next today. We suggest Streams because they do a lot more than data migration, right? You can see there the three options, the three pillars are there. It's very helpful to do cloud adoption, moving from on-prem to cloud, but also do any data integration role. If you have data consolidation coming from multiple databases, getting into cloud, it can do that. It can do real-time database pipeline. But what it does best is, remember, when you do your migration, I always suggest my customers it's a good chance to cleanse your data. Get your data quality right? Because over the years, you have collected this data. Your data quality might have messed up, right? So Streams can do that, doing filtering, doing the aggregation, transformation, all that happens within the Streams. So you achieve two birds in one stone. You're migrating your database to cloud, at the same time taking the opportunity to cleanse data. So Streams can enable that option. And it also shows you visualized screens. There's a demo there after this, which should work, hopefully. Which will show you the process involved of how it's going to do about the example I will show you around Oracle to Spanner, for example.
The Stream wizard-based UI enables users to Cloud Spanner in real time. The Stream wizard-based UI enables users to rapidly create a new data flow to move data to Cloud Spanner. In this example, real-time change data from Oracle will be continually delivered to Cloud Spanner to synchronize Spanner with the on-premise database. The wizard walks you through all the configuration steps, checking that everything is set up properly and results in a data flow application. You can also create an application to perform an initial load. This flow will move the existing data from the Oracle database table to Cloud Spanner. To perform the migration, we'll first start the initial load, followed by applying any changes. Here you can see the table in Cloud Spanner is initially empty. When we start the application, data starts flowing from Oracle to Cloud Spanner. We can monitor the progress through the UI. Once complete, all the rows from the Oracle database are present in Cloud Spanner. Next, we start the CDC application. Any changes that we make in the Oracle database will be immediately reflected in Cloud Spanner, as we can see here. We can also monitor the applications in detail to understand throughput, latency, and resource usage. Streaming Cloud Spanner can change the way you do business. Stream can easily migrate your existing databases to Cloud Spanner without requiring any source application downtime. See how Stream can kickstart your Cloud Spanner initiatives today through the real-time integration to Cloud Spanner offering on the Google Cloud Marketplace.
So Kiran, thank you. That to me was great. You gave me a good view of what's available, of the process to move across. Just tell me, it seems actually like it's not that different from what I would have done on premise. Can you tell me, is there anything specific, any optimization tips that's specific for cloud that you want to highlight for me?
One of the optimizing steps I suggest is how you go about reducing your import time. For example, some tips for optimizing the import time would be importing your data without any foreign keys, importing in primary order. And also monitoring as a part of data getting imported. Is no database is lagging behind. Make sure that enough resources have been allocated for the import. And for that, one of the best features of cloud is, if you build your Cloud SQL database in the GCP, you can allocate memory CPU at the highest level possible. Because remember, it's cloud. You can scale down, scale up anytime. So for import, make sure you get enough memory and CPU is allocated. Start your import, and once the import is done, you can scale it down. You can never do it in on-premise, right? You get a fixed resource when you do in on-prem. This is the advantage of how you can speed up the import. So that's a key there. And also make sure your right amount of storage is assigned when you do the import. So these are the simple, but sometimes people forget to do these things.
And how long will this take me? I mean, this feels like it's possible to do it fast. Is that right?
Yeah, that's a good question, Alfred. So one of our customer, Pantheon, you might have heard, they are the platform to marketeers creating websites worldwide. And these guys, if you can believe there, it has 200,000 websites with MySQL database at the back end, 500 terabyte of data. They did in 2 weeks, going to GCP. And with that, they got better support, but also the cost was reduced by 40%. So they were happy when they moved. And this is in my days, when 10, 15 years ago, it was impossible to talk about this kind of migration, this kind of volume, this kind of complexity moving across. So all this is good, but when you talk about data migration, also you have to remember the application migration. I'm always keeping back. So it is not all about data migration. You have to keep what application you can migrate and how you can leverage other services within GCP to migrate those applications to cloud.
That's amazing. Thank you very much. So tell me, you've now talked about all my structured data, right? And databases and Oracle databases and MySQL databases. But what about my unstructured data? I've got tapes and I've got archives and I've got lots of media files. What do I do with that?
Yes, there will be always more data lying around somewhere under the shed. So for that purpose, I have my friend here, Ash, who's going to give you a wonderful story and what we got in GCP.
Ash, thanks for your help with this. Appreciate that.
Yeah.
Thanks, Kiran. And I've just knocked the water off it the second time today.
I think it's a really excellent question that you asked, Alfred, because moving data to cloud is often a strong prerequisite to getting value from your cloud project across a variety of use cases. Whether you're trying to improve your operational economics, perhaps by moving your archive or backup storage to cloud, or if you're trying to get more value from your data by running analytical or machine learning pipelines. It's also useful when you're trying to lift and shift your apps from your on-premise environment to cloud. In some cases, the business value you're trying to create is the ability to move data in and of itself, to enable collaboration with customers and partners and within your organization. So to help with this, Google has a number of transfer offerings. The first is the Google Cloud Storage Transfer Service, which is a managed service that helps you move data from one Google Cloud region to another, and from other clouds, like AWS, into Google Cloud. The second is the Transfer Appliance. This product helps you move data from your private data center to Google Cloud when you don't have enough bandwidth to meet your project timeline. In that scenario, we will physically ship you the appliance, which you load with data, and then ship back to Google. Finally, if you do have enough bandwidth, you can use gsutil, a command line utility that uploads data from your local file system to Google Cloud Storage over the network. Now, I want to zoom in on this last use case a little bit more. One of the challenges you might have is if you're moving, let's say, hundreds of terabytes or petabytes of data, that's well beyond the capability of any command line tool that's pushing that data over the network. And so customers are often trapped in this situation where they have to build a solution themselves. And there are a lot of challenges that come with doing that. The first is you have to invest a lot of engineering time to get to petabyte scale. And you have to make sure this works across all your networking environments on links that might be lossy or have high latency. The second challenge is that you have to figure out how to get that last 20 or 30% of performance improvement so that you can make the most of your resources that you've allocated. For instance, the bandwidth that you've purchased for your data migration. Then there are other technical considerations. How are you going to make sure that your bytes aren't corrupted while the transfer occurs? How are you going to protect that data while it's in flight? And finally, if your transfer takes days or weeks and it fails in the middle, do you have a way to recover so you can keep the fidelity of your data set secure? And how do you make sure you don't waste time and have to start all over again? So how do you solve this problem? Well, it brings me tremendous pleasure to announce for the first time publicly in any forum that Google has been working on a product that goes to the very heart of this problem. The product that we're announcing is the transfer service for on-premises data, which is rolling out to beta in the coming weeks. This is a managed service for large-scale, over-the-network batch data transfers. And it's principally designed around 3 key customer benefits. The first is to be fast. Fast to set up and fast to move bytes so that you can meet your project timeline. The second is to be easy. so that you can reduce a lot of the personnel costs that go into developing, maintaining, operating, and running your own solution. We want to take all of that pain away. And then finally, we want to make it secure. We want to protect your data in flight from security risks and from data corruption. So let's talk a little bit more about how we do that. So how do we make it fast? So first, to set up our software, you have to install a small piece of software in your private data center called the agent. And we've worked a lot to refine this experience, so all you need to do is cut and paste a few commands into your shell, and in a couple of minutes, you're up and running. This product is specifically designed to move petabytes of data, billions of files at many tens of gigabits per second. It's also designed to be easy to performance tune. So as long as you have the filer throughput and network bandwidth, that those are not bottlenecks for you, running transfers faster is as easy as just running more agents in your private data center. Now, how do we make it easy? So we'll do a quick demo in just a little bit, but suffice to say, I believe that if you can use a web browser, you can issue transfers with this product. The second thing that we do is to reduce the maintenance costs. So our software will automatically update behind the scenes, just like Chrome, so you don't have to worry about that. And finally, this product works on all the connection types you use to connect to Google Cloud. Whether that's a public internet connection, direct interconnect, partner interconnect, it doesn't matter. As long as you can connect to Google Cloud, this product can move your data. Finally, how do we secure this data? Well, the connection between our agent software and Google Cloud is secured by TLS encryption. And we compute checksums at the source and destination to make sure no bits have changed in flight. And we also keep a detailed log of everything that we did so that you can look at this if you so choose. So let's talk a little bit more at the macro level of what it means to walk through this product. So to set up the product, you download a Docker container image. Now this image is more than just like a single process and binary. In fact, it has this self-updating component to it, which I talked about earlier, and it also has a process monitor. So if the agent process dies for some reason, we will bounce it back up for you. You don't have to do any work. Secondly, we encourage you to install multiple agents because then we can parallelize your transfer and get you better performance. Once you've done this one-time setup, then running a transfer is as easy as going into Cloud Console, which is the Google Cloud Platform GUI, telling us what data you want to move, where you want to move it, and hitting go. And then you can monitor progress right inside that GUI without going anywhere else. So we've talked a little bit about it. I'm going to make a silent prayer to the demo gods and try to do a live demo for you right now.
Oh, and so looking forward to see this in action. Thank you very much.
If we could switch to my laptop. I hope you say that little prayer with me. OK, great. So this is the main console for the product. So let's just talk quickly about the setup. So I've set up, if you want to go see what connections our agents are making to the cloud, you can go to Connection Settings. That will show that 60 agents are running. So I'm running these inside of GCE VMs in the US Central region because I don't have a private data center. So that was the easiest thing I could do. And if you want to install an agent, you don't need to go anywhere. The instructions just swap in right here. You can see what commands you need to run. You can cut and paste them and get going. So let's assume that you've set up your agents. Now, how do you go and issue some transfers? So you go to Create Transfer Job, this button at the top. Click Create Transfer. Then you need to give this transfer a name so you can refer to it later. So I'm going to give it a name. Look at those qubits go.
Hey, all my qubits. Thank you. Yes.
Once I've given it a name, I give it the location of my root data. So this is the 15 terabytes of just random data I generated. And now I'm going to choose a bucket in the same region of the VMs. So this is this empty bucket here. And what this means is that you really don't have a lot of bottlenecks in filer throughput or network capacity because you're moving from VMs in the same to VMs in the US Central region to a GCS bucket in the same region. So you're going over internet pipes. So we've picked that destination. I'll choose a subdirectory for where I want my data to go. And then you can schedule your job. We're just going to run it once here, but you can also run this hourly, daily, or weekly, whatever you choose, which is often the case when people are trying to archive or keep data in sync periodically. So we're just going to run it once now for the purposes of this demo, and hit go, and that's it. So what's happening behind the scenes is that we are taking all those 60 agents, we're crawling that directory for all its subdirectories and files, then we're going to the destination and looking over there too, to figure out which files changed or were updated since your last transfer, and we'll only move those files. In addition, we're parallelizing your transfer across all those agents, doing that sharding for you and managing all the state that comes with it. And finally, if there are any errors that occur, we're automatically retrying those under the covers, so you don't have to worry about that. So let's talk a little bit about errors. So if I go back, so you can see this job is running now. I'm going to go to a transfer, same data set that I ran, and I tried to break it. So I deleted a bunch of files while it was running. And we help you look at errors in 2 ways. So there's a bunch of detailed counters in here you can go look at. And you can also go to error details. And in error details, we'll show you a sampling of the errors that we got. So you can do some quick and light troubleshooting. So here you can see this was the error that we got from the OS. We tried to open a file that wasn't there because I went in and broke the transfer by deleting it. The other thing you get is the transfer log. The transfer log is an object which is written to your destination bucket in TSV format, which contains a record of every single thing that we did. What file did we touch? When did we touch it? What was the checksum we computed at the source and destination? And what errors did we get from the OS that weren't resolved by retrying under the covers? And this is in a TSV format, so you can upload it into BigQuery or to the tool of your choice for detailed troubleshooting. Now, let's go to a transfer that actually I did not try to break. This is a transfer that I ran just a couple weeks ago. And just to show you that I actually did run it, you can see that we transferred this about 15 petabyte data set. And I'm going to go now to Stackdriver. Stackdriver is our cloud monitoring tool to monitor your Google Cloud resources, and we're integrated into Stackdriver. All you need to do is set it up. There's no additional cost or anything. This just all comes free out of the box. And there's 2 things you can monitor here. So one, you can go look at what agents are up. And typically you want to do this in case agents go down, so you can go troubleshoot those issues. You can issue alerts. This is probably a good time to talk a little bit about how fault tolerance works in the transfer service for on-premises data. So I have 60 agents running. What happens if 30 of them fail? That's OK. Don't worry. The transfers will keep going. They'll just go a little slower because there are fewer agents to push that data. What if I kill all the agents? Don't worry about that either. Now, transfers won't continue because there are no agents to push data. But as soon as you bring agents back up, we'll just pick up where we left off. No reconfiguration, no retries need to happen. It'll all just work under the covers without your intervention. So now let's talk a little bit about what's on the left-hand side. So this was that transfer that I ran, and you can also monitor per agent throughput if you're trying to do performance troubleshooting. I've just taken the liberty of adding up the aggregate throughput across all the agents. And as you can see, initially, as soon as there's no delay. So as soon as you start finding files, you start moving files. So we want to make sure that there's low latency to the first bytes landing in your bucket. And once you get to a point where you've actually found all the files, then you reach a bit of a steady state where you're now just moving files completely, and there's a little bit of a tail end. And in this transfer, you can see that we ran this at about 18 gigabytes a second, which is about 150 gigabits per second in performance, which is pretty good.
Can you give me a sense how big that is? I mean,
yeah, it's a good question. It's hard to how to conceptualize that. If we could just switch back to the slides, I can help with that. So one way to conceptualize this is to imagine when you're a user of YouTube streaming something to your phone. You're consuming some certain amount of bandwidth. And let's assume for the purposes of this exercise that there are 10,000 attendees at Cloud Next London. I don't know the real number, but let's just choose a round number like that. So one way you could think about this is what percentage of all Cloud Next London attendees would need to be simultaneously streaming YouTube to their phone for the aggregate throughput to be 150 gigabits per second. Any thoughts on what percentage that might be? How many people think that might be 20% of all attendees? OK, got some skeptics. 50%. Any takers for 50%? OK, you're waiting. How about 80%? OK, a couple. 80%. So the answer is 1,000%. So if you took all Cloud Next London attendees, multiplied that by 10, had them all stream YouTube to their phone, that's what 150 gigabits per second is like, just about. Now, just to give a bit of context around this, this isn't an environment where file throughput and network latency is not a problem, because I ran this all in the same region. And typically, in your environment, one of those things will be your bottleneck. But I think the point of this exercise is a little bit of an internal test to show you that if you can scale your filer throughput and your network bandwidth, that this product can scale with you. So let me just recap a little bit about what we talked about. So we announced that we're launching the transfer service for on-premises data into open beta in the coming weeks. This is a managed service for large-scale over-the-network batch data transfers. It's designed to be fast, 2-minute cut and paste setup, billions of files, petabytes of data, multiple tens of gigabits per second. It's designed to be easy. If you can use a web browser, and if you can connect to the cloud from your private data center, this product will work. And finally, it's designed to be secure. Your data is protected by TLS encryption, and we compute bytes checksums at the source and destination, which is all recorded in a log for you to audit later. If you have any questions about this product, feel free to come up to me after this presentation or reach out to your Google account team. Otherwise, you can just wait for this to appear in the Google Cloud Console, the Google Cloud Platform GUI, and we'll be rolling this out to all customers over the coming weeks. Thank you.
Thank you. That is amazing. You know, I've now got so much more confidence. Yes, it deserves a clap. Thank you. It feels like you've got all the different tools that I need to move all of my data. You've got the strategies. You've got the best practices. You've got partners that can do this. And so I'm just filled with confidence that you can help me. Thank you very much, gentlemen. I really appreciate it.
And
so you've seen some of this already. We've got some resources for you on the slide. I want to encourage you to go and have a look at some of our partner booths. We've got a whole collection of partners with good stuff there. So Trifactor gave me the hat. Thank you very much, Trifactor. But we've got Atos and Accenture that can help you with migrating, amongst other things, also your Oracle to Google. We've got Bithian there. We've got PA Consulting there. We've got EMAP, DoIT, Reply, GFT. So a whole bunch of partners, and there are many more that can help you with this. So feel free to go and have a chat with them, or come and talk to us, or if you want to, email us or me.
That's
I like to move it at google.com. It's my email address. So moving data, or have a look at some of the online documentation we've got. There's also some great sessions coming up today and tomorrow, so listed on the slide. I want to encourage you to continue the conversation.
And just want to highlight here, the representative from Streams here. If anybody wants to have a conversation or on offline or contact me, I'm around here. Streams guys are here. If you have on-prem databases you want to discuss, I know we ran through quickly, gave an overview, but there's a lot to discuss because each data migration project is unique. Each customer has its own requirements. You know, setup is different. So it's not one standard template you can use for all of them. So it's a further conversation we should be having then.
Are there any burning questions from any of you that we can answer?
Yeah, I think we have time for a couple questions.
Gentleman there with a hand up. Thank you very much.
So thank you so much for the lovely presentation, and I'm very impressed with the on-premises data transfer service. But my question is, like in the demo it was showing you are transferring into the bucket. Mm-hmm. But if my requirement is like directly transfer into the cold storage for the archiving.
Yeah, so this product works on every single GCS storage class, and it works wherever GCS works. So every location as well.
Okay, thank you.
Any other questions? Just show your hand if you need to. There's somebody with a microphone. Yes, going once, going twice, going 3 times. May the force be with you. Enjoy the day. Thank you very much for your time.
Thank you, guys.
Thanks so much.
Thank you.